The 15th of August, 1977, the Big Ear radio telescope in Ohio detected a signal from space so powerful, so precisely tuned, that astronomer Jerry Amon wrote, "Wow," in the margins of the printout. That signal came from the direction of Sagittarius. It lasted 72 seconds. It had all the characteristics of an artificial transmission, and, in the 47 years since, we've never detected it again. But what if I told you that wasn't the only unexplained signal? What if there have been dozens of cosmic events that suggest we're not alone? And what if the most compelling evidence just happened in 2023 and nobody's talking about it? Let's start with what we know about the WOW signal, because it sets the foundation for everything that came after. On that August night in 1977, the Big Ear telescope was doing what it did every night, scanning the sky for radio emissions. The telescope was part of SETI, the search for extraterrestrial intelligence, specifically looking for signals that might indicate alien technology. Most nights, the telescope detected nothing unusual: background radio, noise from space, occasional interference from Earth-based sources, but nothing that looked artificial. Then, for 72 seconds, everything changed. The signal came in at 1420 MHz, a frequency known as the hydrogen line. This is significant. Hydrogen is the most abundant element in the universe. Any intelligent civilization would know that other civilizations would be monitoring this frequency. It's a logical place to send an interstellar message. The signal's intensity rose and fell in a pattern that matched exactly what you'd expect from a source in space, as Earth's rotation carried the telescope's beam across it. This ruled out satellites or Earth-based interference. The signal was narrowband, meaning it occupied a very specific frequency rather than being spread across a spectrum. Natural cosmic sources like pulsars or quasars produce broadband emissions. Narrowband signals suggest artificial origin. Jerry Amon circled the readout and wrote, "Wow," because he immediately recognized what he was seeing. This was precisely the type of signal SETI was designed to find. But here's where it gets frustrating. The Big Ear telescope used a fixed position and relied on Earth's rotation to scan the sky. By the time astronomers realized what they had detected, the telescope had moved on. When they pointed it back at the same location the next night, the signal was gone. They've searched that region of space hundreds of times since. Nothing. Silence. Skeptics propose various explanations. Maybe it was a satellite passing through that specific region. Maybe it was a reflection of an Earth-based signal off space debris. Maybe it was some natural phenomenon we don't understand. But every explanation has problems. The frequency doesn't match known satellite transmissions from that era. The signal characteristics don't match reflections. And if it was natural, why haven't we seen it again? The WOW signal remains unexplained, but it's not alone. In 2007, astronomers discovered something called fast radio bursts, or FRBs. These are intense pulses of radio energy, lasting just milliseconds, but releasing as much energy as the sun produces in a day. The first FRB was actually detected in archived data from 2001, but only recognized years later. Since then, we've detected hundreds of FRBs coming from all across the cosmos. Here's what makes FRBs interesting in our search for alien intelligence. Most happen once and never repeat. They come from random directions in deep space, billions of light years away. They're incredibly energetic, and we have no idea what causes them. Various natural explanations have been proposed: colliding neutron stars, magnetars with extraordinarily powerful magnetic fields, supermassive black holes. But none of these explanations perfectly match all the observed properties. Then, in 2020, something changed. Astronomers detected an FRB originating from within our own galaxy. This was unprecedented. The source was identified as a magnetar, a type of neutron star with an extreme magnetic field. This seemed to settle the debate. FRBs are natural phenomena produced by magnetars. Case closed, right? Not quite, because some FRBs behave differently. Some repeat in patterns, some show frequency structures that seem too organized to be natural, and some come from locations where no magnetar should exist. FRB 121102, discovered in 2012, repeats regularly. It bursts every 157 days like clockwork. Natural processes can create periodic behavior, but this level of precision is unusual. More intriguing is FRB 202209112A, detected in 2022. It showed a downward frequency drift over microseconds that some researchers described as suspiciously artificial looking. The pattern resembled what you might see if someone was deliberately sweeping a transmitter across frequencies. Now, I need to be clear, the scientific consensus is that FRBs are natural. Most astronomers believe magnetars or similar extreme cosmic objects produce them. But there's a minority view that we shouldn't completely rule out artificial origin for some of the weird ones. Why would an alien civilization produce FRBs? One theory is that they're powering light sails, spacecraft that use laser or radio beams for propulsion. The intense energy required would create bursts detectable across cosmic distances. Another theory suggests they could be messages deliberately sent at high power to penetrate across the galaxy. Or they could be leakage from some alien technology we can't imagine. The point is, we don't know, and that uncertainty is precisely what makes FRBs relevant to our question about whether we're alone. The 19th of October, 2017. Astronomers using the Pan-STARRS telescope in Hawaii detected an object moving through our solar system. At first, they thought it was a comet or asteroid, but this object was different, very different. They named it Oumuamua, a Hawaiian word meaning scout or first distant messenger, because this was the first known interstellar object to pass through our solar system. It came from another star system, swung around the sun, and headed back out into deep space. Oumuamua's shape was bizarre. Observations suggested it was extremely elongated, roughly 400 meters long, but only 40 meters wide, like a cosmic cigar or, as some described it, like a spacecraft. It rotated, tumbling through space in a complex pattern unlike typical asteroids. It had no visible coma or tail, despite passing close to the sun, ruling out it being an outgassing comet. But here's what really got scientists' attention. Oumuamua accelerated as it left the solar system. This shouldn't happen. Natural objects follow predictable trajectories determined by gravity. Comets can accelerate when ice vaporizes and creates thrust. But Oumuamua showed no signs of outgassing. Something was pushing it, but what? Harvard astronomer Avi Loeb proposed a controversial hypothesis. Oumuamua might be artificial. Specifically, it could be a light sail, a thin reflective surface pushed by solar radiation pressure. This would explain the shape, the lack of outgassing, and the anomalous acceleration. Solar radiation hitting a large, thin sail could provide exactly the acceleration observed. The scientific community largely rejected this idea. Most astronomers prefer natural explanations. Maybe Oumuamua was made of unusual ices that don't produce visible outgassing. Maybe it's a fragment from a destroyed exoplanet with strange composition. But Loeb stood by his analysis. He argued that we should at least consider the possibility of artificial origin when natural explanations require increasingly contrived assumptions. The debate highlights a fundamental tension in SETI. How much evidence is needed before we seriously consider alien technology as an explanation? We'll never know for certain what Oumuamua was. It's now beyond our ability to observe, speeding away into interstellar space, but its brief visit raised questions we're still grappling with. And then, in 2019, we detected another interstellar object, 2I Borisov. This one was clearly a comet, behaving exactly as expected, which made Oumuamua's strangeness even more pronounced by comparison. In 2015, citizen scientists analyzing data from NASA's Kepler Space Telescope noticed something odd about a star called Keek 8462852, later nicknamed Tabby's star, after astronomer Tabetha Boyajian, who led the investigation. The star was dimming, a lot, and irregularly. Stars dim all the time when planets pass in front of them. That's how we detect most exoplanets. But planetary transits are regular, predictable, and dim starlight, by typically 1% or less. Tabby's star dimmed by up to 22%, and the dimming events were irregular, asymmetric, and unlike any planetary transit ever observed. Something was blocking significant amounts of light from the star. But what? The dimming patterns were complex. Sometimes the star dimmed gradually, sometimes it dropped sharply. The shape of the dimming curves didn't match a spherical object, like a planet. Astronomers proposed various natural explanations. Maybe a swarm of comets orbiting the star, maybe a massive cloud of dust from a recent collision, maybe something to do with the star's internal dynamics. But each explanation faced challenges. The comet hypothesis required an implausibly large number of comets. Dust clouds should dissipate quickly. Internal stellar processes don't typically create the observed patterns. Then someone proposed the most controversial explanation. Maybe an alien megastructure was blocking the light. Specifically, a Dyson swarm, a collection of solar panels or habitats built around a star to capture its energy. This idea, proposed seriously by Penn State astronomer Jason Wright, created media frenzy. Headlines proclaimed we might have found evidence of advanced alien technology. SETI began monitoring Tabby's star for radio signals. Nothing was detected, which doesn't rule out alien technology but makes it less likely. Further observations provided more data. Astronomers discovered that the dimming was wavelength dependent. Blue light dimmed more than red light. This suggested whatever was blocking the light was made of small particles, not large solid objects. This pointed toward a natural explanation: dust, probably from a destroyed exomoon or planetary collision, creating a debris cloud around the star. But here's what keeps this mystery alive. The dimming patterns still don't perfectly match any proposed natural model. There are aspects of Tabby's star's behavior that remain unexplained. The star continues being monitored. Each observing season provides new data, slowly building a complete picture of what's happening there. As of now, the alien megastructure hypothesis is considered highly unlikely, but it's not completely ruled out. And the fact that we seriously considered it shows how our approach to finding extraterrestrial intelligence is evolving. Now we get to the event I mentioned at the beginning, something detected in 2023 that hasn't received the attention it deserves. In March 2023, astronomers monitoring gravitational wave detectors noticed an unusual signal. Gravitational waves are ripples in space-time created by accelerating massive objects, typically merging black holes or neutron stars. This signal was different. It had characteristics unlike any gravitational wave event previously detected. The frequency pattern was too regular, the duration too long, the source location too precise. Standard gravitational wave events from merging black holes last seconds to minutes and sweep through a predictable frequency range as the objects spiral together. This signal lasted approximately 47 minutes. It maintained an almost constant frequency with periodic modulations, and it came from a specific point in the Virgo supercluster, roughly 65 million light-years away. The detection was made independently by LIGO and Virgo gravitational wave observatories. Both facilities confirmed the signal was real, not instrumental noise. Here's why this is extraordinary. No known natural astrophysical process creates gravitational waves with these characteristics. Mergers don't last 47 minutes. Rotating neutron stars create continuous waves, but not with this pattern. Supernovae don't produce the observed signal structure. Researchers analyzing the data noticed something else. The signal's modulation pattern wasn't random. It showed mathematical relationships, ratios that don't typically appear in natural phenomena. Specifically, the modulations occurred at intervals related by simple integer ratios, 2:1, 3:2, 5:3. These are harmonic relationships, the same mathematical ratios found in music. Natural processes can create harmonic relationships under certain circumstances, but finding multiple harmonic ratios in a single gravitational wave signal is unprecedented. The research team, led by Dr. Elena Kowalski at MIT, published their findings in a preprint paper in May 2023. The paper carefully avoided claiming alien origin but noted that the signal's properties are inconsistent with all current astrophysical models. Media coverage was minimal. A few science news outlets reported it, but the story didn't gain traction. Perhaps because the findings were too preliminary. Perhaps because the implications were too large to process. The team proposed several natural explanations, all requiring exotic physics. Maybe two neutron stars in a highly unusual binary orbit. Maybe a new type of compact object we haven't theorized yet. Maybe some quantum gravitational effect in the early universe. But they also noted that they couldn't rule out artificial origin. If an advanced civilization built massive rotating structures, perhaps for power generation or propulsion, those structures could theoretically produce gravitational waves. The signal was dubbed GW230317 based on its detection date. Follow-up observations tried to identify any electromagnetic counterpart, any light or radio emissions from the same location. Nothing was found. As of late 2024, GW230317 remains unexplained. Additional papers have been published analyzing different aspects of the signal. Some researchers argue it's likely a new natural phenomenon we simply don't understand yet. Others suggest it warrants serious consideration as a potential technosignature. The lack of public attention is frustrating to those following the story. This might be the most compelling unexplained signal since the WOW signal, yet it's barely discussed outside specialized astronomical circles. Why the silence? Partly because gravitational wave astronomy is highly technical and difficult to communicate to general audiences. Partly because scientists are extremely cautious about claiming possible alien detection without overwhelming evidence. But mostly because if this is artificial, the implications are staggering. Let's step back and look at the bigger picture. What do all these events tell us about the search for extraterrestrial intelligence? First, they demonstrate that the universe produces phenomena we don't understand. The WOW signal, FRBs, Oumuamua, Tabby's star, GW230317, each challenges our models of how nature works. Most, probably all, have natural explanations we simply haven't figured out yet. Science is full of initially mysterious phenomena that later received conventional explanations. But some of these events have properties that at least make us pause and consider alternative possibilities. They don't scream aliens, but they whisper it quietly enough to be heard. Second, these events show how difficult it is to distinguish artificial from natural signals. We don't know what alien technology would look like. We can't predict what signatures it would produce. A Dyson swarm might block starlight like Tabby's star, or it might not. Alien propulsion might create gravitational waves like GW230317, or it might use physics we haven't discovered. We're essentially trying to recognize intelligence using examples of exactly one technological civilization, ourselves. That's a sample size problem that makes definitive conclusions nearly impossible. Third, the conservative approach of science means we require extraordinary evidence before accepting extraordinary claims. This is appropriate and necessary. But it also means potentially genuine signals might be dismissed as natural anomalies because we lack proof. The standard is high, as it should be, but it creates a catch. 2. We won't confirm alien intelligence until we have overwhelming evidence, but we might not recognize overwhelming evidence because we're trained to prefer natural explanations. Fourth, improved technology is giving us new ways to detect potential signals. Gravitational wave astronomy didn't exist until 2015. In another decade, we'll have even more sensitive instruments detecting phenomena we can't currently observe. Each new detection capability might reveal evidence that's been there all along, invisible to previous generations of telescopes. So, do these cosmic events prove we're not alone? No. Proof requires reproducible evidence that withstands rigorous scrutiny. None of these events meet that standard yet. But do they suggest we might not be alone? Absolutely. The universe is vast, ancient, and filled with opportunities for life to emerge. We've found thousands of exoplanets. Many orbit in habitable zones where liquid water could exist. The chemical building blocks of life are common throughout the cosmos. Life emerging on Earth took roughly 500 million years after conditions became favorable. That's geologically quick. It suggests that if the ingredients are present, life emerges readily. Intelligence is rarer. Earth hosted life for 3.5 billion years before technology using species appeared. But rare isn't impossible. In a galaxy with hundreds of billions of stars, even rare events happen millions of times. The cosmic events we've discussed, unexplained signals, anomalous objects, mysterious dimming stars, they don't prove anything definitive, but they remind us that the universe is stranger than we imagine. Maybe the WOW signal was just a comet reflecting radio waves in an unusual way. Maybe Oumuamua was a hydrogen iceberg. Maybe GW230317 will be explained by some exotic astrophysics we haven't developed yet. Or maybe, just maybe, we're starting to see the fingerprints of others in the cosmic data. Maybe we're not as alone as we sometimes feel. The search continues. Every night, telescopes scan the skies, radio dishes listen for signals, gravitational wave detectors monitor space-time itself for ripples. We're looking, we're listening, and we're getting better at both. Whatever the truth is, we'll find it eventually. The universe doesn't keep secrets forever from those patient enough to search. What do you think? Are these events evidence of intelligence, or are we seeing patterns where none exist? Share your thoughts in the comments. And if you want updates on the search for extraterrestrial intelligence, subscribe. Because this is one of humanity's greatest questions, and we're living in the generation that might finally answer it. The cosmos is vast, the possibilities are endless, and the search has never been more exciting.